like Auguste Dupin, will we have simply upgraded our software? Or will we have accidentally engineered the spark of a soul?
So, imagine being publicly compared to Leonardo da Vinci.
Right. Not a bad compliment.
Yeah, not bad at all. Imagine having your intellect placed on the exact same pedestal as, like, Roger Bacon. And imagine Noam Chomsky, who is, one of the absolute titans of modern linguistics and philosophy.
Absolutely.
Right. Imagine Chomsky stating on the record that you are the thinker to whom he feels closest, and that his own groundbreaking work is practically just paraphrasing yours.
Which is a staggering thing for someone like Chomsky to admit.
It really is. I mean, you'd think a person with that kind of resume would be a household name, right? You'd assume they'd be in the pantheon of history right next to Einstein or Tesla or Edison.
You would. But history doesn't always work out that way.
Exactly. Because now I want you to imagine that same person dying completely obscure, freezing in this dilapidated house, literally complaining that they were too poor to afford a single piece of firewood.
It's incredibly tragic.
And worse than that, their foundational work, like the actual blueprints on computing and logic and how the human mind actually works, is locked away in a basement for 40 years.
Yeah. It is honestly one of the most glaring, uncomfortable paradoxes in the history of American intellectualism.
For sure.
Because you have this man, Charles Sanders Peirce, whom historians and biographers have flatly called the most important mind the United States has ever produced. And he dies in absolute squalor.
Right.
But the tragedy of his life is really just, it's just the doorway into a much larger, much more profound puzzle.
And that puzzle is basically our mission for this deep dive today. We are undertaking a really rigorous step-by-step analysis of this incredibly dense chapter of intellectual history. It's called '09, The Puzzle of Peirce.
A very fitting title.
Yeah, exactly, because we are going to unpack the biography of this forgotten American genius. But more importantly, we are going to use his life's obsession to sort of deconstruct the hidden mechanics of human cognition.
The literal architecture of how you and I actually think.
Right. And finally, we're going to explore why artificial intelligence, despite, the billions of dollars in endless hype we see today, is fundamentally stuck.
Because it's missing a piece.
A missing piece of logic that Peirce mapped out over a century ago. A piece that separates true dynamic intelligence from just a really fast calculator.
It's a phenomenal trajectory to track. Because Peirce's life serves as the ultimate framing device for what philosophers call the puzzle of inference.
Inference.
Right, which is this cognitive leap that allows us to make sense of the world. Peirce spent his entire life trying to mathematically map this highly specific act of the mind, and society just didn't want to hear about it.
And then later, computer scientists basically built an entire industry by completely ignoring it.
To their own massive detriment, I might add.
Right, exactly. So to understand why modern AI struggles to possess, basic common sense, we actually have to go back to Victorian Massachusetts. We have to figure out why the man who solved the problem was buried by history.
Let's do it.
So I want to start by trying to understand this polymath profile. Because Peirce was not some outsider looking in.
No, not at all.
He wasn't a starving artist who came from nothing. He was born in Cambridge, Massachusetts in 1839 into the absolute upper echelon of Victorian scientific culture.
The elite of the elite.
Right. His father was an eminent professor of mathematics at Harvard. His cousin was Henry Cabot Lodge, who was a massively powerful U.S. senator.
So he grew up just breathing the air of elite academia.
Totally. And he graduated summa cum laude from Harvard's Lawrence Scientific School in 1863.
He had every conceivable advantage. Pedigree, wealth, access, and just raw, unadulterated genius.
Yeah.
Max H. Fish, who is a scholar who dedicated much of his life to studying Peirce, put it very bluntly.
What did he say?
Well, when asked who the most original and versatile intellect the Americas have ever produced is, Fish argued the answer is completely uncontested.
Yeah.
Nobody else is even worth nominating.
Wow. Uncontested. But, to understand why he said that, we have to look at the breadth of his expertise.
It's dizzying.
It really is. In a modern context, we are incredibly specialized. You have astrophysicists who, only study one specific type of quasar, or chemists who spend their entire lives on a single protein fold.
Right. We silo our intelligence today.
Exactly. But Peirce was an astronomer, a mathematician, a chemist, and an inventor. And he didn't stop at the hard physical sciences either.
No, he was a philologist, a lexicographer, a historian of
A
science.
phenomenologist, a logician, and a semiotician. Oh, and just for fun, he was an actor and a dramatist.
Right, because why not throw acting into the mix?
I mean, seriously.
Yeah.
And he spent 30 years doing these painstaking topological studies of the Earth's surface for the U.S. Coast and Geodetic Survey, measuring gravity intensity.
And he was the first American delegate to any international scientific association. It defies modern comprehension.
It really does. How does one brain do all of that?
Well, there is a fascinating cognitive quirk that helps explain how his mind was able to synthesize so many disparate fields. He possessed a deeply nonlinear way of processing information.
Okay, what do you mean by nonlinear?
Well, like Einstein, Peirce was left-handed, and he processed complex concepts visually rather than strictly verbally.
I want to dig into that for a second, because when we think of mathematical or logical genius, we usually picture, someone writing out massive equations on a chalkboard.
Right, Goodwill Hunting style.
Yeah, exactly. Linear algebraic symbols. If A equals B and B equals C, then A equals C.
But Peirce approached it topologically. He sketched out logical inferences as mathematical diagrams.
Diagram.
Yeah, he created something called existential graphs. So instead of writing out a linear string of logic, he would map it on a page, what he called a sheet of assertion.
Oh, wow.
He would use intersecting lines, boundaries, and spatial relationships to represent how different concepts interacted or, contradicted one another.
So he is basically drawing the architecture of an idea.
Precisely. He was translating the invisible mechanics of thought into a visual spatial landscape.
Which sounds amazing, honestly.
It is, but there was a massive downside to this brilliance.
I can imagine.
Yeah. Toward the end of his life, his few remaining friends, including the pioneering psychologist William James, managed to organize a series of lectures for Peirce at Harvard.
Okay, kind of a comeback tour.
That was the goal. The idea was for Peirce to explain the foundations of logic and his program for thinking clearly. But his visual spatial approach completely baffled his audience.
And we are not talking about a room full of random undergraduates here.
No. William James was arguably one of the greatest minds of the era and Peirce's closest friend.
Right.
Yet James later admitted that he could not follow the lectures. He confessed that the mathematics attached to Peirce's pictures and diagrams were simply beyond his comprehension.
Wait, really? William James couldn't understand it?
He couldn't. The concepts were operating on a frequency that even the most brilliant Victorian academics couldn't tune into.
Which I guess resulted in the lectures going largely unnoticed.
Exactly. They were only published in book form decades later. His mind was so advanced and his method of communication so radically different that he was essentially speaking a foreign language to his peers.
But, I struggle to accept this purely intellectual explanation for his downfall.
How so?
Well, you're telling me a guy with family connections to U.S. senators, a summa cum laude Harvard pedigree, and a mind compared to Da Vinci was completely marginalized just because his lectures were hard to follow.
It sounds a bit thin, doesn't it?
Yeah. I mean, history is full of incomprehensible geniuses who were still given tenure and celebrated. There has to be more to it than him just being a difficult lecturer. How do you go from Harvard royalty to dying in a freezing shack?
You hit the nail on the head. The intellectual barrier was only a small piece of the puzzle. The real mechanism of his marginalization was deeply sociological.
And entirely self-inflicted, from what I understand.
Absolutely. Peirce was constitutionally incapable of playing by the rules of Victorian society. He was, to put it mildly, a walking PR disaster for any institution that tried to hire him.
Right, he engaged in a sort of relentless professional self-destruction.
He burned every bridge, seemingly on purpose.
Give me an example.
Let's look at his 30-year career with the U.S. Coast Survey. This was a prestigious government position, but the government ultimately fired him because he fundamentally refused to adhere to bureaucratic reality.
Like he just wouldn't do the paperwork.
Exactly. He would fail to deliver crucial reports on time, and during a tour of Europe, he somehow managed to lose expensive, highly specialized government equipment.
Oh, man. Okay, so he's fired from the Coast Survey.
Then he pivots to academia, landing a lectureship at Johns Hopkins University.
Which is a prime opportunity.
It is, but he is dismissed after reports of unspecified, quote, unbecoming conduct.
Yikes. Unbecoming conduct in the Victorian era could be anything.
Right. And then there is Harvard, the institution where his father was a titan, the absolute center of his universe.
They blacklisted him, right.
They flat out refused to ever offer him a professorship. And that was because of a known infidelity in his marriage, followed by a very messy divorce and a quick remarriage to a mysterious French woman named Juliette, whom polite society deemed an outcast.
Ah, so the Victorian socialites of New England practically bolted their doors when they saw him coming.
Exactly. Even William James, who loved him, recognized the sheer volatility of the man.
Didn't James write a letter about him when they were younger?
He did. When they were young students at Harvard, James wrote a letter to his family describing Peirce as a very smart fellow, but warned that he was pretty independent and violent.
Violent.
Yeah. Later in life, James would sympathetically but accurately refer to him as that strange and unruly being.
So he becomes the ultimate outcast. A man who mapped the intricacies of human logic but possessed zero emotional intelligence or political savvy.
None.
But the tragedy here isn't just about a man losing his social standing. The real catastrophe is what happened to the work itself.
That is the real loss for humanity.
Because he was radioactive, because he attracted scandal and irritated everyone in power, his scientific and philosophical papers were effectively quarantined.
They were locked away in Harvard's Houghton Library, just gathering dust. Volumes of incredibly prescient insights into logic, semiotics, and computing remained sealed until 1956.
Which is 42 years after he died.
Right.
And what's truly infuriating is the reason they stayed locked away.
It was money, wasn't it?
Yeah. Lewis Mumford later pointed out that they lay untouched simply for want of a few $1,000s to guarantee the initial expense of publication.
Unbelievable.
No one in the academic community was willing to pony up a few grand to publish America's greatest intellect simply because they didn't want to invite the scandal associated with his name.
And frankly, the few who did look at the papers likely didn't understand the scope of what he was proposing anyway.
True. Pure intelligence, no matter how profound, is impotent if the society it exists in refuses to engage with it.
Exactly. So Peirce's early work on computing was forgotten. He is known today primarily in philosophy departments as the founder of pragmatism.
Right.
But the enormity of his contribution to cognitive science, to the actual mechanics of thought, was delayed by half a century.
Which means the fields of computer science and artificial intelligence developed in the mid-20th century without access to his foundational blueprint.
They were flying blind.
Which brings us to the core of what was actually inside those locked boxes, the obsession that defined Peirce's life. We have to dive into the central epistemological problem he was trying to solve.
The nature of inference.
Exactly.
This is where Peirce stops being just a tragic historical figure and becomes the architect of cognitive science. He recognized that inference is the engine of the mind. It is the fundamental process that separates a living intellect from a dead rock.
Okay, let's ground this for a second by looking at the word itself. Etymologically, inference is a noun derived from the verb infer. It comes from the Latin in, meaning into, and fer, meaning to bring or to carry. So literally, to infer means to bring about. You are bringing about a new thought.
That's a great way to frame it.
But if you look at the Oxford English Dictionary, they define it as a cognitive action. To reach an opinion or decide that something is true on the basis of information that is available.
And on the surface, that sounds reasonable.
Right, it sounds totally fine.
But that definition contains a critical, pervasive flaw that Peirce spent his life trying to correct.
Oh, it's the flaw.
The OED lists deduce as a synonym for infer, and equating inference with deduction is a massive philosophical error. It fundamentally misrepresents how human beings actually navigate the world.
Okay, let's break down the difference, because I think we use those words interchangeably all the time in casual conversation.
We do, but they are very different. Deduction is rigid. It is mathematically certain.
Like the classic Aristotelian syllogism.
Exactly. If all men are mortal, and Socrates is a man, then you can logically deduce that Socrates is mortal.
Right. Deduction doesn't create new knowledge about the world. It just unpacks what is already logically contained within the premises.
Yes. If the premises are true, the conclusion is guaranteed. But everyday human inference, the kind Peirce was obsessed with, is completely different. It is not a mathematical guarantee. It is an expansion of knowledge.
And you can see this broader, messier reality even in the everyday usage examples the dictionary provides.
Right, like what?
Like, much of the meaning must be inferred from the context, or readers are left to infer the killer's motives, or it is reasonable to infer that the government knew about these deals.
Exactly. None of those are strict deductions. You cannot mathematically prove a killer's motives based on airtight logical axioms.
No, you definitely can't.
What you are actually doing is taking what you already know, your prior knowledge of the world, human psychology, politics, and combining it with a new, present observation to bring about a new belief.
You are updating your mental map of reality.
Yes. Inference is a leap. It is a guess that we deem reasonable based on the surrounding context.
And this continuous updating of beliefs based on context is the absolute bedrock of intelligence.
It is the defining feature.
A cognitive agent, whether that is a human being, a dog, or an AI system, cannot be considered intelligent if it cannot infer. The ability to use what is known and observed to navigate a changing reality is the very definition of a working mind.
You can't understand a joke without inferring the unspoken context. You can't develop a vaccine without inferring a biological mechanism.
You can't even cross a busy street without inferring the trajectory and speed of the oncoming cars.
Right.
Let's walk through a real-time, mundane example from the text to show just how incredibly complex this invisible process actually is.
The Pepsi can example.
Yeah, the Pepsi can in the kitchen. So imagine I wake up, I walk into my kitchen, and I see a half-empty can of Pepsi sitting on the counter.
Right.
Instantly, before I even consciously register what I'm doing, my mind tries to explain it. I might infer that my sister left it there.
And why do you make that specific leap?
Because my prior knowledge dictates that my sister drinks Pepsi, and my present observation is that she happens to be staying at my house this week.
Right. That is a classic inference. Prior knowledge plus present observation equals a new belief. But the genius of human cognition is that it doesn't stop there.
No, because the context is always richer and the mind processes it dynamically.
Exactly.
So my brain immediately counters that first thought. I remember that there are contractors in the house redoing the countertops. I observed one of them drinking a Pepsi yesterday.
So maybe it's the workers' can.
Right. But wait, I also know that I was drinking a Pepsi on the back porch last night and left it unfinished. Perhaps my spouse brought my can inside and left it on the kitchen counter to throw away later.
So in a fraction of a second, your brain cycles through multiple complex narratives, weighs them against an enormous web of background knowledge, and selects the explanation that makes the most sense in that exact moment.
And I do all of that without breaking a sweat.
We all do. It is real-time processing, adapting to variables that are shifting second by second. We think in time.
This is the part that I find so profound. We take this completely for granted because we don't even notice it happening. This constant churning engine of inference is essentially the background radiation of consciousness.
That's a perfect way to describe it.
We are always doing it. We don't bother inferring things we already know with absolute certainty, like the fact that gravity exists or that our hand is attached to our arm.
Right, there's a need.
We only use inference to pierce the veil of the unknown, to get to new knowledge. If we had to consciously, deliberately calculate every single variable to figure out who left the Pepsi can,
We would freeze.
completely freeze. We would be trapped in what philosophers call solipsistic loops, just endlessly chasing our own thoughts, utterly paralyzed and unable to act in the real world.
That phrase, the background radiation of consciousness, is so helpful because it highlights how invisible the process is to us. But this invisibility also hides the dark side of inference.
The dark side.
Yeah, because inference is inherently provisional, because it is a contextual leap rather than a mathematical certainty, it is highly fallible.
Okay.
When we rely on prior knowledge, we are often relying on prejudice, bias, or just incomplete impressions.
Which leads to hasty, incorrect conclusions.
Right.
Like, for example, the text mentions a scenario where someone is late to work. Say I arrive at the office 20 minutes late. My boss immediately infers that I'm slacking off, that I don't care about my job, and that I'm unprofessional.
But the reality is that a semi-truck flipped over on the highway and traffic was at a complete standstill.
The boss made a rapid inference based on a pre-existing assumption about my character combined with the observation of my lateness.
The mechanism of inference worked perfectly, but the conclusion was completely wrong.
Wow, yeah.
This is why in casual conversation, we often use the word infer negatively. We say things like, Susie is inferring all sorts of crazy things about you after that joke you made.
So Susie is executing a cognitive leap, but her prior knowledge is contaminated by her own insecurities or maybe just a bad mood.
Exactly. So inference is this incredibly powerful, constant engine, but it is deeply provisional. It requires guessing.
And that requirement, the necessity of guessing based on a fluid, infinite web of context, is precisely what makes human inference so unimaginably difficult to program into a machine.
Which brings us to the collision between Peirce's map of the mind and the modern pursuit of artificial intelligence.
Right. If inference is the messy, contextual background radiation of human thought, what happens when computer scientists try to replicate it using rigid binary code?
Historically, it results in absolute failure.
Tell me about it.
We run face first into the knowledge versus application dilemma. In the early days of AI, researchers understood that in order for a machine to infer anything, it first needed prior knowledge.
Makes sense. A system that doesn't know anything can't make sense of new observations.
So they adopted a brute force approach. They essentially tried to build a mechanical god by feeding it an encyclopedia of everything.
Literally just typing in facts.
Yes. Projects emerged where engineers spent years manually coding millions of facts, logical rules, and axioms into databases. They thought, if we just teach the computer that water is wet, that gravity pulls down, that sisters drink Pepsi.
It will magically achieve intelligence.
Right. But they hit a brick wall known as the frame problem, or the needle in a haystack problem.
What's that?
They discovered that a system with millions of facts still has absolutely no idea which fact is relevant in a dynamically changing environment.
Because relevance isn't a property of the fact itself.
Exactly.
The fact that my sister drinks Pepsi isn't inherently relevant to the universe. It only becomes relevant in the highly specific context of me walking into my kitchen and seeing a specific can on a specific day.
How do you write a mathematical formula for relevance when the variables are infinite and constantly shifting?
You can't.
You can't. Relevance is a human judgment. The system would have to search its entire massive database of facts every single time it encountered a new piece of data just to determine what applies.
Which raises a fundamental question about what we even consider intelligence.
It does.
If an AI system is just a massive repository of data, executing keyword searches to spit out a pre-programmed response, is it actually intelligent? Or is it just a really fast filing cabinet?
A filing cabinet is all it is, because true intelligence requires the application of knowledge in real time.
The real-time part is key.
This time requirement is critical. Imagine a supercomputer that is tasked with navigating a robot across a busy street.
Okay.
The computer has all the data about physics, velocity, and mechanics. But if it takes the computer 10 billion years to calculate the exact trajectory of every oncoming car to ensure a mathematically perfect route...
The robot will be crushed in 3 seconds.
Exactly. A program that calculates perfectly but fails to act in time possesses exactly zero intelligence.
True cognition has to operate within the constraints of time. It has to react. And to react in time, you cannot calculate every variable. You have to make a leap. You have to guess.
Yes, you have to guess.
This reminds me of the classic literary detectives from the text. The author brings in Edgar Allan Poe's character, C. Auguste Dupin.
The predecessor to Sherlock Holmes.
Right. To illustrate this exact point, Poe was adamant that in the realm of true analytical thinking, human insights are not derived from mathematical formulas. He explicitly wrote that these insights exist beyond the limits of mere rule.
Dupin solving the murders in the Rue Morgue is a perfect example of this.
How so?
He surveys a bizarre, chaotic crime scene, and he arrives at the explanation that an orangutan committed the murders through what appears to be a serendipitous, almost magical leap of intuition.
Right. Now, he later verifies this leap by investigating and finding the owner of the animal. But that initial spark, that moment of insight, was he just guessing?
Yes. But it wasn't a random guess. It was an educated, contextual, deeply human guess. And that makes it a vitally important kind of inference, one that completely sidesteps calculation.
And this is where we have to ask, how did the entire field of artificial intelligence miss this?
It's a great question.
How did thousands of brilliant engineers spend decades trying to build intelligence through rigid calculation, completely ignoring the necessity of the contextual guess?
To answer that, we have to look at the father of computing himself, Alan Turing,
Okay.
and a massive shortcut he took that inadvertently sent the entire field down a blind alley. Let's deconstruct his famous 1950 paper, Computing Machinery and Intelligence.
This is the document that essentially launched the quest for AI, right?
It is. In that paper, Turing is trying to lay the groundwork for how we might build and measure artificial minds. But he runs into a philosophical roadblock.
Which is?
People keep asking him, but can a machine actually think?
Right, the million-dollar question.
Turing decides that the word thinking is hopelessly subjective, messy, and unscientific.
So what does he do?
He uses a brilliant but ultimately dangerous analogy to dismiss the question entirely. He says that asking if a computer is thinking is as ridiculous as asking if a submarine is swimming.
Oh, I see.
We all agree that dolphins swim, right? It is a biological dynamic act. A submarine propels itself through the water using mechanics and rotors. It navigates the ocean, it gets from point A to point B, but we don't call it swimming because we don't anthropomorphize the machine.
Turing argued that if a computer can play chess and beat a human, Who cares if it is thinking the way a human thinks? It got the output.
Exactly. It was a radical, incredibly effective rhetorical move. By defining intelligence strictly in terms of observable outputs, can it play chess, can it translate Russian, he bypassed the entire philosophical debate about the internal mechanics of the mind.
He folded the messy, unprogrammable reality of human insight entirely into the sphere of mechanical computation.
Yes.
I mean, I understand why he did it. It allowed computer scientists to just get to work. They didn't have to solve the mysteries of consciousness. They just had to write code and build better hardware.
Right, but the fallout from that shortcut was devastating.
It was a catastrophic omission.
Because he folded insight into computation, the fundamental question was ignored. How does mechanical calculation ever translate into the fluid, contextual inference exhibited by humans?
The entire field of AI was birthed without a working theory of inference.
Yes.
Which leads to a deeply unsettling analogy from the source text. Trying to build artificial intelligence without a theory of inference is exactly like a team of engineers trying to build an atomic bomb armed only with the equation ECGT.
It is a perfect parallel. Knowing that energy equals mass times the speed of light squared is a brilliant theoretical insight.
But it does not tell you how to build a bomb.
Not at all. To build the bomb, you have to understand the physical mechanics of nuclear fission. You need to know how to trigger a chain reaction.
In the same way, knowing how to process binary code and build neural networks is not enough to build a mind. You have to understand the cognitive chain reaction.
You have to know how a mind actually brings about a new thought.
Because Turing bypassed this, the field of AI suffered through decades of false hopes and dead-end paths.
We had eras known as AI winters, where funding completely dried up because these systems, which could calculate math at light speed, couldn't understand the context of a simple children's story.
They tried to build a mind without a blueprint.
And to truly grasp just how massive the gap is between mechanical computation and true human insight, we have to look away from machines for a minute.
Okay, where do we look?
We have to look at the absolute zenith of human thought. We have to look at the history of scientific discovery.
Oh, this is where the argument becomes undeniable, because we are taught a very specific, highly sanitized myth about how science works.
The mechanical myth.
Yeah, think back to your grade school science fair. You are taught the scientific method as a mechanical recipe.
Step 1.
Yeah.
Observe the world and gather data.
Step 2. Logically deduce a hypothesis from that data. Step 3.
Oh.
Run an experiment. Step 4. Scientific progress.
It is a comforting myth because it makes discovery seem programmable. But anyone who studies the history of science knows that groundbreaking, paradigm-shifting hypotheses are never arrived at mechanically.
They do not emerge from an algorithm.
No. In reality, the most profound insights often simply pop into a scientist's head after years of immersing themselves in the field.
But because we like logic and order, historians of science often treat these leaps of genius as if they're just, happy accidents.
They push the central act of intelligence outside the formal boundaries of science, treating it as if it just rides along for free.
Let's shatter that myth by looking at one of the most famous scientific revolutions in history. Copernicus redrawing the solar system.
A perfect example.
We are taught that Copernicus looked at the data and logically deduced that the Earth revolves around the sun, overthrowing the ancient Earth-centered Ptolemaic model.
But the historical reality is entirely different.
Set the stage for us.
So for centuries, astronomers operated under the Ptolemaic system, where the Earth was the center of everything. But the data didn't cooperate. Planets didn't move in perfect circles around the Earth.
Right. If you observe Mars in the night sky over a period of months, it generally moves eastward. But periodically, it seems to stop, reverse direction, and move west for a while, and then turn back east.
It's called retrograde motion.
Yes.
And to explain this erratic behavior without abandoning the Earth-centric model, ancient astronomers invented a mathematical nightmare called epicycles.
Epicycles?
Yeah, they hypothesized that Mars wasn't just orbiting the Earth in a large circle, it was simultaneously spinning in a smaller circle along that orbit, like a cosmic loop-de-loop.
Which sounds crazy.
It was. But as telescopes got better and observations became more precise, a single epicycle wasn't enough to make the math work. So they added epicycles on top of epicycles.
It became a wildly convoluted, dizzying mathematical monstrosity just to force the data to fit the model.
Enter Copernicus.
Right.
The mechanical myth says he analyzed all this accumulating data and logically deduced the sun was at the center. But he didn't.
He actually ignored the mountains of established Ptolemaic data, didn't he?
He did. He didn't crunch the numbers harder. He looked at the monstrous complexity of the epicycles and essentially said, "This feels wrong. It's too ugly."
So he executed a conceptual leap. He imagined a completely different architecture, placing the sun at the center.
And here is the fact that absolutely blew my mind when reading the source.
What's that?
When Copernicus first published his heliocentric model, it was actually less accurate at predicting planetary movements than the old convoluted Earth-centered model.
Wait, really? It was less accurate?
It was, because Copernicus still believed orbits had to be perfect circles. His initial sun-centered math didn't quite line up with the reality in the sky.
Oh, wow.
The old system, for all its monstrous complexity, had been fine-tuned over centuries to predict exactly where a planet would be on a given night. The Copernican model was mathematically inferior at first.
That is wild.
It was simply a new conceptual framework, an inspired guess that offered a more elegant structure.
So let's ask the AI question. If Copernicus had access to a modern supercomputer and the ultimate big data set of every astronomical observation ever made up to that point, would the machine have logically output the heliocentric model?
Absolutely not. All the big data in the world would have been utterly useless for discovery because all the data was perfectly tailored to fit the wrong model.
Right. If you fed millions of data points into a machine learning algorithm designed to optimize the Ptolemaic system,
The computer would have just calculated more and more complex epicycles. It would have reinforced the error.
the machine optimizing data cannot guess outside of its own programmed framework.
Exactly. It took a human mind to reject the framework entirely and make an inspired leap.
Let's look at a second case study to drive this home. Johannes Kepler.
Right.
Kepler is the man who finally fixed the Copernican model by discovering that planets don't move in perfect circles. They move in ellipses ovals. Now, the common assumption is that Kepler chose the ellipse because it was mathematically the simplest solution. You always hear about Occam's razor, the idea that the simplest explanation is usually the correct one. So, was an ellipse just simpler than a circle with an epicycle?
No, and it's a critical misconception. The text points out that there are an infinite number of geometric shapes and complex curves that can be mathematically mapped to planetary orbits.
You could use egg shapes, you could use spirals.
Exactly. The ellipse was not chosen because it was the mathematically inevitable or simplest output.
So if it wasn't mathematically inevitable, why did Kepler choose an elliptical orbit?
Because, as he admitted, he conjectured an explanation that simply felt right to him.
Felt right.
Yeah. He was a deeply religious, mystical thinker who believed in the harmony of the spheres. He made an imaginative, aesthetic guess that an ellipse was the harmonious shape of the cosmos.
A scientific breakthrough based on something that felt right. That is the absolute antithesis of a programmable mechanical algorithm.
Exactly. The undeniable fact that scientific revolutions are driven by intuitive conjectures completely shatters the mechanical account of science.
Whether it is a detective solving a murder, a scientist redrawing the universe, or a normal person figuring out who left a soda on the counter, these are all dynamic workings of the mind.
They are leaps.
And if AI researchers ever want to build generally intelligent machines, they have to figure out how to account for this specific type of leap.
Which brings us back, at long last, to the hero of our story, Charles Sanders Peirce.
And the paper is locked in the Harvard archives.
Yes. If scientific revolutions and everyday common sense are both reliant on guesses that feel right, what is the underlying logic tying them together?
Peirce answered this question by identifying a massive blind spot in the history of philosophy. He realized that the accounts of logical reasoning, stretching all the way back to Aristotle, were fundamentally incomplete.
They were. For thousands of years, classical logic was built on two primary pillars. The first, as we discussed, is deduction. It is mathematically certain, but doesn't generate new knowledge. If A is B and B is C, then A is C.
And the second pillar is induction.
Yes. Induction is how we establish probabilities based on repeated observations.
Like, if I pull 100 beans out of a bag and every single one is white, I use induction to conclude that all the beans in the bag are probably white.
Right. It is highly probable. But unlike deduction, it is not absolutely certain. The 101st bean could be black.
Okay, so Peirce looked at deduction and induction and realized that neither of them explains how Copernicus reimagined the solar system.
Neither explains how Dupin solved the murder. Neither explains how you process a joke.
He realized there had to be a third pillar of logic.
And he found it. He called it abduction, or abductive inference.
Let's define this clearly, because this is the holy grail. Abductive inference is defined as the explanatory guess.
Yes, the explanatory guess.
It is the cognitive leap from a surprising observation to a hypothesis that would explain it.
It is the missing piece. It defies traditional mathematics because it isn't certain like deduction, and it isn't based on repeated statistical sampling like induction.
It is a single intuitive leap that makes sense of a specific context.
Abduction is the logic of discovery. It is the process of generating the hypothesis in the first place before you can ever use deduction or induction to test it.
And when you map this concept of abduction onto the modern struggles of artificial intelligence, everything clicks into place.
It really does. It explains exactly why the Turing test is so incredibly difficult to pass.
The Turing test asks a machine to converse via natural language text in a way that fools a human into thinking they are talking to another human.
Yes, and language processing is the ultimate abductive minefield.
Because conversations aren't equations.
Exactly. When you and I talk, we are rarely speaking in literal, complete logical statements.
We use slang, metaphors, sarcasm. We leave half our thoughts unsaid, assuming the other person will fill in the blanks based on our shared cultural and physical context.
Every single exchange in a fluid conversation requires an abductive leap. You are constantly guessing my intended meaning based on the context.
You are bringing about a new belief based on an explanatory guess.
And computers fundamentally do not guess. They calculate.
So if Peirce had been alive to witness the birth of artificial intelligence, what would he have said?
He would have immediately identified its fatal flaw. He would have seen that the problem of abductive inference confronts AI with its central, still entirely unsolved challenge.
Peirce isolated the exact cognitive function, the explanatory guess, that supercomputers still cannot replicate today.
He had the blueprint all along.
We have covered an immense amount of ground today.
We really have.
We started with the tragedy of C.S. Peirce, a man who possessed a mind so vastly advanced that he had to draw visual maps of logic, yet was utterly incapable of navigating the social realities of Victorian society.
And we saw how his marginalization buried the true nature of inference, leading dictionary writers to equate it with rigid deduction, and leading Alan Turing to bypass the mechanics of human thought entirely with his submarine analogy.
We looked at how attempting to build intelligence with just brute force facts and rules leads to the haystack problem, where a machine knows everything but understands nothing about context.
And we proved through the leaps of Copernicus and Kepler that true intelligence, true scientific discovery, relies not on big data, but on the deeply human art of abduction.
I want you to take a moment and realize just how extraordinary your own mind is. Every time you read between the lines of an ambiguous text message from a friend.
Every time you walk into a room and instantly assess the mood.
Every time you have an aha moment where disparate pieces of information suddenly click together to form a new idea, you are executing a complex abductive maneuver.
You are performing a cognitive leap of such profound complexity that the world's most powerful multi-billion-dollar supercomputers still cannot fathom how you do it.
Which leaves us with a final provocative thought to ponder.
What's that?
If our greatest scientific revolutions, our deepest moments of personal understanding, and even our most basic daily conversations are ultimately based on unprogrammable guesses that simply feel right,
Yeah.
does that mean true artificial intelligence will never be achieved until we figure out how to program a machine to trust its gut?
Wow.
Because right now, AI might be the most complex, impressive calculator we have ever built, but it is still just pointing at a screen